Welcome to the Visual COBOL in a Nutshell series of presentations. This module will cover using dynamic SQL statements with OpenESQL technology. So what do we mean by dynamic SQL? Well, dynamic SQL comprises those statements whose content is determined dynamically at program execution time instead of at compile time like static SQL statements. An example of a case where dynamic SQL could be used would be an application that allows the user to select the columns to include and sort sequence of a generated report. Another example would be a query that is executed against a table which is created during program execution. Dynamic SQL statements are used by placing their text within a host variable which is then passed to the database for execution. Parameter markers specified by a question mark in OpenESQL can appear within the statements to represent a user-specified value that will be supplied at execution time. Here is a comparison. In static SQL, the entire text of the statement, including host variables, appear within the exec SQL block and can be processed at compile time. The same statement in dynamic SQL is placed within a host variable which is then prepared and executed. Parameter markers are used within the statement and host variables are substituted at execution time. In OpenESQL, there are basically four types of dynamic SQL statements that can be used. Type 1 is used when a statement only needs to be executed once. Type 2 is used when a statement may be executed more than once using a different set of parameter data. Type 3 is used when you need to return a result set using a select query. And Type 4 is used when the number and types of input and return parameters is unknown in advance, making it truly dynamic processing. Let's take a closer look. Type 1 uses exec SQL execute immediate to execute a SQL statement that resides in a host variable. When using execute immediate, certain rules apply. The statement cannot perform queries that return data other than a SQL code value, so select statements are not supported. The statement must also directly specify any required data, as parameter markers cannot be used. Type 1 statements work well for executing DDL statements like create table and create procedure. Dynamic SQL statement type 2 uses exec SQL prepare to compile a SQL statement that may contain parameter markers. Once that statement is prepared, it can be run many times using the execute statement, and a different set of parameter data can be used each time. Again, certain rules apply. A type 2 statement using prepare and execute cannot perform queries that return data other than a SQL code result, so select statements are not supported. You can, however, use parameter markers in the statement and supply necessary host variable data when the statement is executed. Dynamic SQL statement type 3 uses exec SQL prepare to compile a SQL select query that may also contain parameter markers. Because a select statement is being used that will return a result set, the prepared statement needs to be associated with a cursor. When the cursor is open, the prepared statement will be executed and any parameter markers will be replaced by the data in a corresponding host variable. One or more result sets will then be made available to the application using the standard fetch statement on that open cursor. Rules that limit the type 1 and type 2 SQL statements do not apply here. Before we cover the dynamic SQL type 4 statements, let's take a quick look at these first three types of statements in action. Okay. So this is Visual COBOL for Visual Studio 2012. I have a simple program that will demonstrate what we just covered for dynamic SQL statements. Okay. We'll start this up using the debugger by pressing the F11 key so we can step through the program. It contains some host variables and a data item called SQL buffer, which has a picx 500. We'll use this SQL buffer to construct our dynamic SQL statements. Then we have some data items that we can use to construct our tables dynamically. This is using ODBC and SQL Server. The same program will run under ADO.NET using an ADO provider as well. So we connect to our table. The first statement that we'll demonstrate is the type 1 statement using execute immediate. Here we use it for some DDL. We just move the contents of the statement into the SQL buffer and then just execute the SQL buffer. Okay. So in the type 1 statement, all text for the statement must be in the host variable, including any data that's being used, as parameter markers are not supported. Here we generate a new statement into the SQL buffer using string. You can use any method to get the data into the buffer before doing a execute on it. You can get the data from a file or from a user. That doesn't matter. It's just that when you before you process, the SQL buffer must contain a valid SQL statement. And here we can see that it has a create table along with all the columns that we want in that table. So we'll execute that and commit it. Okay. We can also use the execute immediate for other types of statements, such as the insert or update. But again, all the data must be provided in the statement, as parameter markers are not supported. So here we have an insert statement in the SQL buffer, and we execute immediate, and that is processed. Okay, for type 2 statements, it uses a prepare, and you can use parameter markers as question marks to denote where your parameters, where host variables will provide data to the statement when it's executed. So here we just move that statement in, and now we prepare it, and the prepare references a new statement name called my statement from that SQL buffer. Okay, so that will pass this on to the database to compile it and get the statement ready for use. Now that it's been prepared, we can populate host variables with data and then use the exec-SQL execute on this my statement that we just prepared, and then pass it to host variables that will replace the parameter markers. Okay, so we can execute it once. Once it's prepared, we can reuse that prepared statement for different data. So now we can execute it again without preparing it, just passing the same host variables. And once again, we can execute it. Okay. We can also use it for an update statement using multiple parameters. So here we're using different types of parameters where we set the cust phone to a value and then use in the comparison for the where clause another parameter marker. Okay, we prepare that statement, populate the host variables, and then execute it and pass the appropriate host variables to the execute. Okay. Type 3 statements are used for selecting data and queries. So we populate our host variable, our SQL buffer, with our select statement. We can use parameter markers. Here we're using it in the like. Okay, we prepare that statement, and then we have to associate it with a cursor using declare cursor for my statement. And remember, my statement is the name used in the prepare. Okay, now you can fill in your host variable with the compare value, open the cursor. Now you can just fetch it as if it worked the same way as the static SQL statement. So no difference there. And this should display two rows of data. Then exit. Okay, you can also use Dynamic SQL for stored procedure calls. Here I'm just going to use some static SQL to drop the procedure and create it. Okay, we could have used Dynamic SQL in that instance also. But when you're using Dynamic SQL for stored procedures, you need to enclose the entire statement in braces, left and right braces. And you can include parameter markers and the in-out directional parameter specifiers. So here we prepared this stored procedure. Okay, and then we just use the execute statement the same way we did before, and we pass the host variables, which will replace the parameter markers. And we commit that. Dynamic SQL statement type 4 can be used when the number and types of the input and return parameters of a SQL statement are unknown. With type 4 statements, the SQL DA or SQL descriptor area data structure is used to hold information about parameters and results that are being used in the prepared statement. By setting some initial values in the SQL DA structure and then executing a exec SQL describe or a prepare into for your prepared statement, OpenESQL will populate the fields of the SQL DA structure with the column names, data types, and lengths of the columns that will be returned when the prepared statement is executed. The application can then set the pointer fields within the SQL DA structure to reference an appropriate host variable memory area that will be used to store the result data returned from the select statement. When using fetch to retrieve the rows, you would specify the using descriptor phrase and reference the populated SQL DA structure. This is what the SQL DA copy file looks like for OpenESQL. On input, you would set SQL D ABC to the length of the structure being used, and SQL N would be set to the maximum number of columns that can be returned. After executing describe or the prepare into against your prepared statement, SQLD will be set to the number of columns that actually will be returned, and the SQL var table will be filled in for each column. Before executing the SQL statement, you would set the SQL data and SQL IND pointers to the address of an appropriate host variable or indicator variable for each column described. After executing your statement and fetching the rows, the data for each specified column will be placed into its appropriate memory location. Let's take a look at how this works. Okay, we'll jump back into Visual COBOL. We have another demo program, this one to demonstrate the SQL DA use. In our working storage, we do not have any host variables defined directly, as all host variables will be allocated dynamically using the CBL alloc mem routine. Okay, we do have an include statement to bring the SQL DA structure into the program. If we open that up, we take a look at what this looks like in OpenESQL. We can see that there are various fields, and then there's a table here that will occur one time for each column that will be in use, and that defines the type of column, the length of the column, and then the name of the column. And depending on if you're using 64-bit or 32-bit, the length of this structure can vary slightly. Okay. At the bottom of the copybook are a number of constants that define the SQL types for the data items returned in the columns, whether or not it's character data or varchar or integer, etc. Okay. We also have defined in the linkage section two items here for the types that we know about, the integer and character, for this demonstration so that we can display the data. We'll set the pointers to these variables so that we can display the values returned. Okay, so we'll start this up, press F11 and connect. And the statement that we'll be working with is select asterisk from MF customers, where cust company is like a parameter that we pass in. So since we're saying select with a wildcard, we don't know the actual columns that will be returned. So that's a good candidate for using this type 4 statement with the SQL DA. Okay. Prior to using the SQL DA, we have to set the SQL N to be the number of columns, the maximum number of columns that we expect. And then you compute the size in the SQL D ABC field. The calculation is a little bit different for 64-bit. You use the value 56 instead of 44. Okay, so 32-bit here. And then we can prepare our statement which uses the SQL buffer for our select statement. And then you can describe it. Now we have a choice here, an alternative. If you, instead of using the prepare followed by the describe, you can combine both those statements using the prepare into SQL DA. That does a combination of the two. But here, after preparing, we'll use the describe. And the describe will fill in the SQL DA structure with the data that we need. If we take a look at that, we can see that what it passes back in the SQL D, that contains the number of columns that will be returned, and that's set to 4. And if we look at our table, we should see that there will be 4 entries in there. And there are customer number, contact, company, and phone are the columns that will be returned. And if we look at each one of those individually, we can see that there's a type set and a length set for each one. Here the type is 496, which means that's an integer. If we were to look at the second column, that has type 452, which is a character column with a length of 30. So we know what type of host variable we need. Okay. If we continue running this, what this statement will do is, based on the information that was returned, it will go into a perform loop, varying a subscript for once through for each of the columns that are returned. And we do a CBL alloc memory. So we use the length parameter returned to allocate a data area of memory with that length. And then we return a pointer, which we're setting directly as the SQL data, which is in the SQL DA structure itself. So we do that once for each. Okay, so now our pointers are set. We move S% to our compare value, so we return rows that the company name begins with an S. We open our cursor, and now in the fetch, instead of doing a normal fetch where we fetch into a list of host variables, we use this using descriptor and specify the SQL DA. And so it will use that to determine the pointers of the host variables and the length, and it will fetch the data into that. Okay, so each time through we're going to display the returned data, and you can see that it's a little more complicated to use the SQL DA, the type 4, than it is the other types of statements. But if you want true dynamic performance and dynamic capabilities, this is what you can use. So each time through we'll display the name that was returned. If the type is an integer, we'll set the address of that linkage section item so that we can display it to the pointer and display it. Okay, if it's a character type, we'll set it to the character variable in the linkage section and display that. So it does this once for each column, and then it will fetch again and fetch the next row, and we'll go through each column again. And there are only 2 columns that will match beginning with an S, so we're done. We close our cursor and then free the memory that we allocated for the host variables. And before doing our disconnect, we'll take a look at what was displayed. We can see that here it displays the column name, the value of the column for each of the columns, and the 2 rows that were returned. So that's how the SQL DA works. And that brings us to the end of this Visual COBOL in a nutshell presentation of using Dynamic SQL with OpenESQL technology. Thank you for watching, and happy programming.